The function was x to the 4 e to the 7x. To find the domain, you have to look at the denominator, and since I didn't have one, that means that all of the x values are all real numbers, and so I did negative infinity to positive infinity. And then for the x and y intercepts, for x-intercept, you set the function equal to 0, and then you solve for x. So I got x equals 0, and I plugged it back into the function, and you end up getting this ordered pair. And then for y-intercept, you plug in 0 into the function for the x value, so y equals 0 to the 4, e to the 7 times 0, and you end up getting y equals 0. And again, you plug that in, and you get this ordered pair. For asymptotes and holes, the horizontal asymptote was the limit as x approaches negative infinity of f of x equals 0. I didn't have any vertical asymptotes or holes because, again, I didn't have a denominator, but to find vertical asymptotes, you take out the holes. Holes are like common values on the top and bottom that you take out and set equal to 0, but the vertical asymptote is when you set the denominator equal to 0. This function had 2 critical points, so to find that, you take the function and get the first derivative, which is this here, and then you set it equal to 0. I find that's easier to factor out something, and then you can set both of those equal to 0, and so I got x equals 0, x equals negative 4 over 7. You plug that back into the first derivative to get the points, and that's what you get. This is the decimal form of negative 4 over 7. For intervals of increasing and decreasing, you take that first derivative, and if it's greater than 0, it's increasing, and if it's less than 0, it's decreasing. So I picked points that were in between 0 and negative 4 over 7, and I got a negative number. And then I took one that was less than, I did negative 7 over 7, and I got a positive value, so it's increasing. And over here, I used positive 1, and it was increasing. Those critical points are kind of like plateaus where it's going flat. It's not necessarily a curve. And using that little line that we drew, you can find the local max and the local min. The local max is at the negative 4 divided by 7. I plugged it into the first derivative and got 0.002. And then the local min was at 0, 0. And again, you can look at that line. This was the local max. This was the local min. To find concavity, you have to find the second derivative. And so that right there is the second derivative. And you set equal to 0, and then you're going to have to take out a common value to make this easier. So I took out x squared e to the 7x, and I set that equal to 0 and got x equals 0. But everything else right here, the 49x squared plus 56x plus 12, you have to set that equal to 0 and use the quadratic formula, and you get x equals negative 6 over 7, and then you get negative 2 over 7. And so with that, you take those 3 points and put them on a line, and then you're going to do what we did with the intervals of increasing and decreasing. You'll have to take values that are like less than to figure out that this is concave up, in between, concave down, in between, concave up, and above 0, concave up. So again, just plug in a value to that second derivative, and it'll tell you if it's positive or negative, so that you can do this. And then inflection points are what I circled. You get in decimal form, you get negative 0.857 and 0.001, and over here it's negative 0.286, and then that's 9.019 times 10 to the negative 4. So again, you're going to have to put the concavity into ordered pairs. So concave up was negative infinity to negative 6 over 7 in union with negative 2 over 7 to 0 in union with 0 to positive infinity. And then concave down was negative 6 over 7 to negative 2 over 7.